Niall Clancy is a freshwater ecologist who, in early 2026, will finally be the boss of his own research group at Salish Kootenai College in western Montana. He has spent the last several years specializing in non-game species, the fish that he admits aren't particularly pretty, don't grow very large, won't take a fly, and definitely don't taste good. Niall is joining the Leave It to Beaver series because he has spent a suspicious amount of time in beaver ponds, whether it's seining them near Havre, Montana, or constructing beaver dam analogs near Buffalo, Wyoming. He wrote a paper on bull trout passage at beaver dams, determining that while beavers are great at building, they don't always provide a convenient elevator service for migrating trout. His research suggests that while beavers help create resilient ecosystems, we might need to seasonally notch their work if we want to make trout make it to the party upstream. When he isn't calculating pool to jump ratios, Niall is busy promoting his Ice Age hangover hypothesis, which I suggest asking him about, which is a scientific way of saying that fish that moved in right after the glaciers left are now finding the modern world a bit too warm for comfort. He holds a PhD from the University of Wyoming and a Master's of Science from Utah State and a BS from Montana State, proving that he will collect degrees almost as fast as he collects samples of torn sculpin and bigmouth buffalo. In his limited free time, Niall enjoys expeditions to bookstores and watching baseball. Through his website suggests he spends an equal amount of time waiting for the tow truck at remote field sites. He is the editor of a book advising the next generation of biologists to know what the hell they're talking about. A standard he tries to live up to every time he's knee-deep in a prairie stream. So please welcome Niall Clancy.
Well, thank you, Ryan, for that introduction. And sounds like you've read more of my work than I have. But thanks, everyone, for showing up. Part of my goal for the talk today is, kind of as Ryan alluded to give the kind of unvarnished both sides of the story of beaver. Beavers have historically been maligned and trapped, and ranchers still hate them mostly. But people are increasingly realizing that they have a lot of benefits. And so as an academic, a scientist, my role is to just attempt to evaluate the facts, see what the science says, and go from there. And so my hope is that you'll come away from this talk not necessarily believing that beavers are the best thing in the world or the worst thing in the world. You'll come away with kind of a realistic understanding of when they can help and when they can hurt. So that's kind of where I'm coming from and how I want to start this talk off. But to get going, I want to first do a short lesson in history about why beavers, or how beavers have really driven American history. So when the Pilgrims came over, a lot of us are told that American history is a story of people that were escaping religious persecution and, getting away from English tyrants, which was true for the Massachusetts Bay Colony for approximately 6 months before they started fighting with the natives. But most of the history of America, and especially colonial America, is what Bill Clinton's advisor used to say, which is, it's the economy, stupid. And this has been true for basically all of time. And this is really how America got founded. What happened was there were a bunch of companies with commercial interests that saw this new world where there were plenty of new resources and plenty of things that they could harvest and sell back home. And so the very first thing that they looked for was gold. The Spanish had been down in South America. They were bringing all this gold back to Europe. And so the English and the French thought, oh, that looks pretty good. They went over, not too much gold that they found right off the bat. But what they did find was a little plant that if you dried it up and smoked it, gave you a little bit of a buzz, and that was tobacco. But that really was only growing in in the deep south, in Virginia and south of there. What really kept people coming over here, the main resource that people were looking for, was beaver pelts. And I'm going to pass around a beaver pelt here. Feel free to kind of give it a feel. You'll notice there's kind of two layers to this beaver pelt. There's these guard hairs, and then there's a undercoat, a very fine fur. So I'll start right here. Go ahead and, it doesn't matter. So go ahead and pass that around. You'll notice that under fur is very fine. And the reason that they were getting these was to bake hats. And one thing you'll notice as I pass around this hat that I found at the thrift store the other day is that when beaver fur is felted, it makes this really fine kind of interwoven material that can actually repel rain. It's so tightly woven. So I'm going to pass this around too. Go ahead and give that a feel. And one thing I was noticing when I was in that thrift store looking for this hat was that anything that was beaver fur, you could feel it right away. I didn't even have to look at the tag to tell it was beaver. It's incredibly tightly woven. And this was the height of fashion from about 1600 through the mid 1800s. And so Europe was crazy for beaver hats, not just for the extremely wealthy that would be wearing the top hats, but for just the common folk too. While it was initially a luxury product, once beavers started flowing in from North America, it became a very popular product for everyday hats, including, the colonial tricorn hats that we're familiar with. Good. And the reason they were looking for those in North America was because Eurasian beavers had been basically completely trapped out. So their historical range went all the way from Western Europe into basically the Far East and Siberia. But by the time that they were looking for new sources of furs, really just those dark patches were what was left over from that historical distribution. So there were basically very, very few Eurasian beavers left to trap and to make these hats. So when they came over to the Americas, the way this generally worked is that, if you think about it from a company's perspective, this is a big risk that they're taking. They're going into a new uncharted land. They're paying a lot of money to get goods from Europe and explorers from Europe over to North America. And so a lot of times that's too much risk for just a single company to take on. And so governments would step in and they would sponsor these companies and these trappers. And that's why initially England and France and Holland were particularly involved in establishing had an invested interest in establishing the fur trade, so they could basically support these companies that were risky and too big to fail. And so as they would go through North America, they mostly would pay the natives to bring them furs. So they had some trappers of their own, but at least initially, a lot of the actual trapping was done by the Native Americans, and they would supply the furs to these trappers. And as each of these three countries, and Holland's kind of got beat out of the race early, but France and Britain really started competing for these trapping lands. And what happened was there would be inevitable conflicts. And tribes, they weren't stupid either. They saw, hey, here's these guys' commercial interests. They're willing to trade us ammunition. They're willing to trade us axes, metal goods, and we can use this against our other tribal enemies. And so what happened was you had these alliances formed where France would sponsor certain tribes, Britain would sponsor the rival tribes, and that basically led to a lot of conflict, including what became known as the 7 Years' War, or in North America, the French and Indian Wars, which is really the precursor to the Revolution. So it was really all driven by the need for beavers. And what you saw was the establishment of military forts throughout North America to basically protect these trapping regions. So this is a picture of what was called Fort Duchesne, which is on the confluence of the Allegheny, the Monongahela, where they formed the Ohio River. Can anyone tell me what city sits there today? Pittsburgh. Yeah, you guys are better geography than I was. So a lot of major American cities actually started out as military forts that were established to protect fur trappers and their interests. And so once the American Revolution took place, what we saw was the establishment of American companies and in British Canada of British companies. And a lot of times these companies were just known for the areas where they started initially trapping. So the Ohio Company was one of the first ones, the Northwest Company later on, the Pacific Northwest, Rocky Mountain Fur Company, which trapped a lot of this area. There's even the Russian American Company, which trapped a lot of Alaska. And then, the well-known Hudson Bay Company up in Canada. That was one of the British companies. And then the American Fur Company, which basically trapped much of the Pacific Northwest and the West. And that actually spawned their president, their founder, John Jacob Astor, was the very first millionaire in America. So this was big money. This was the Tesla. This was the SpaceX. This was the Amazon of the day. And these companies, these American companies, sponsored some of the most well-known mountain men that we have. So top left there, that's Jim Bridger, Kit Carson, Jeremiah Johnson, and Jedediah Smith. A lot of these guys made their living guiding and trapping for these fur companies. So many of the people that established the West as we know it were working on behalf of these commercial trapping interests. So this map just kind of shows where a lot of the fur trapping happened, and you basically progress from east to west. And there's different commercial interests in different areas with kind of overlaps and rivalries. There's companies buying other companies that owned rights or had most trappers in certain areas. And basically the expansion of the United States was in large part driven by kind of that first line of people. Those were trappers that were moving into new areas, and that's where a lot of the conflicts were driven from. So essentially, my argument here is that beavers and the fur trade were one of the, if not the most important driver of manifest destiny, of the expansion west, and of American history itself. This graph shows essentially the number of furs, and you can kind of get an idea of when the majority of furs were harvested. And this is just reported numbers, but this is per decade how many millions of beaver pelts were recorded at outposts throughout the 1600s to the early 1900s. You see you get this large spike in the 1700s. A lot of that is the Ohio River Valley moving westward. A lot of the early 1800s is the West, Pacific Northwest a little later on, and essentially trapping out beavers as they go. So because of all of this, the pre-colonial beaver population, which was estimated, you see estimates that are kind of all over the place, but it basically went from about 100 to 200 million to something on the order of about 100,000, which if you do the math, that's 0.05% or 0.1%, somewhere in there. So very much decimated the beaver population of North America. Now, sometimes you'll hear, they were trapped to near extinction. They weren't trapped to near extinction. They were never on the order of being trapped out and, to the degree where we weren't ever going to have beavers. There were still isolated populations, but they were certainly functionally extinct, meaning that their dam building activity just wasn't, there was so few dams out there that they were no longer having a major impact on the ecosystem. Today, we're sitting at somewhere between 5 and 15% of that historical population. So we've certainly recovered from those historic lows, but a lot of the interest you see generated around restoration is really driven by this recognition that we're still sitting at a fraction of what beavers would have looked like in the past. So the first speaker in this seminar series was Dr. Ellen Wool from CSU. And this is one of her students' work that estimated basically how far off of historical populations we are in Colorado. And if you look at these different kind of ecosystems across Colorado, you can see the current dam density, which is dams per kilometer, compared to the historic dam density. Some systems, like the plains, would have never had large beaver populations, and sit actually about to where, roughly approximately the same number of dams across the plains. But if you look at the mountains and like the Rio Grande, you'll see that we're at a fraction of the number of dams across those streams and those ecosystems. So it depends on the ecosystem you're looking at, but especially in the mountains, we're still at a fraction, and the mountain valleys especially is where we have a huge deficit of beavers compared to the historic numbers. Okay, so why do we care? Why is beaver activity such a big deal? Well, for one, why do beavers, why are they building dams in the first place? What you see, if you look at this little GIF of this beaver walking, is that if you're a coyote, or if you're a wolf or a cougar, that's basically a walking cheeseburger right there. They are not moving anywhere fast. And basically, the only way for a beaver to escape predation is for them to build dams, because underwater, none of those predators can get them. So basically, dam building evolved to avoid predation. And through this activity of dam building, they have all sorts of behaviors that have arisen. The beavers have adapted to once they have this underwater lifestyle, and that's having caches of willows and other plants underwater, of building their lodges out in the middle of these ponds. All of that was an adaptation to this aquatic lifestyle that was really meant to avoid predation. So this is what a healthy beaver population, healthy complex of beaver dams looks like. For those of you who know the area, this is about an hour north of here near Laramie. That's Turtle Rock, which is a popular climbing spot out by Laramie. And this little creek that's running near Turtle Rock is absolutely loaded with beaver dams. And what you can see is that there's this huge diversity of habitat, right? You have the center of the pond, which is kind of like a pelagic zone for you limnologists out there, kind of the center of a lake where you have low productivity, but can really generate a lot of refuge habitat for fish and other critters. And then, on the sides of these habitats, you get lush vegetation, so really healthy riparian communities. And a lot of times I get asked, if you've got a whole series of beaver dams, it's like, does one beaver do all this? Well, usually it's a family of beavers. And what a family of beavers usually consists of is two adults, so the parents, the mom and the dad. Then they'll have the teenagers, which are usually from 1 to 2 years old, and then the kids, which are the newborns. And once a beaver hits about 2, it will go out on its own. They usually don't go more than about 10 miles away from home, but every once in a while you get a beaver that'll cruise off for 100 miles or something, but most of them stay relatively close to home. And it's basically through the successive generations of these related beaver families that you get these large beaver complexes. And if left undisturbed, if they're not trapped out, that's when you really get large beaver complexes. So this is a picture of what we think is the largest beaver dam in the world. This is up in northern Alberta, and this dam is about half a mile long. It's larger than Hoover Dam. It's 17 acres of water. For reference, the largest dam that I've ever seen, which was in this totally remote rural part of Wyoming, was about 10% of this size, and I thought that thing was absolutely massive. So left undisturbed for a really long time, they can completely alter. They can basically turn a stream into a lake. So here's a video of one of the beaver ponds that I studied. And what you can see is the stream starting up here, flowing down and around, and back up. Could you restart that video real quick?
I can try.
So one thing I want you to notice is just the diversity of different types of habitats. No big deal if not.
There we go.
Anyway, so you see the water flowing down here. It's really ponded through here. And then you get these kind of run-of-river dams. And then just a whole series of dams that are actually creating all of this. There's actually water underneath all of these trees. So you just create an incredible diversity of habitat where you would have had a single threaded channel. Now you have a stream that's popping up and over its banks, flowing around, creating little side channels. And in ecology, diversity begets diversity. Meaning if you have diversity on the landscape, that supports more diversity of plants, that supports a higher diversity of animals. So when it comes to the benefits of beaver, what we really see is this increased habitat diversity, which in turn leads to a lot of thermal diversity. So if you look at a beaver complex, what you tend to see is that kind of in the center, in those big open water zones, you have slightly warmer than normal temperatures. But one thing you'll see a lot of people worry about is how are we changing the temperatures, right? Is the stream going to get a lot warmer if beavers are there? It matters where exactly you measure that temperature. And in the middle of the pond, yes, it may be warmer. If you go down a few feet, though, towards the bottom of the pond, it's going to be a lot cooler. One of the things that beaver ponds do is that beaver ponds sit a lot higher than the stream below them. So there's this elevation difference between a pond and the outflow. And what happens is it's forcing water into basically the shallow groundwater. And it's going down into that groundwater where it cools off substantially before coming back up into the stream. And so basically, if you look at how a stream's temperature changes through a beaver complex, it's basically a wash. You're not changing the temperature too much one way or the other. It depends on the system. To a degree, some places it does get a little warmer, some places it doesn't. But for the most part, those temperatures stay about the same. Another thing you see is that wetland plants proliferate along beaver ponds, which makes a lot of sense because you're raising the water table. So that water table comes up, you're storing that water, it's spreading it out across the landscape, you get a much higher diversity of wetland plants. And so one of the other things that you hear about beaver dams is that they're really good at storing water. You also hear people say that beaver dams are useful in retaining water and increasing downstream late season base flow. The idea that they capture, little feedback here in the mic. The idea is that beaver dams capture water and then store it and slowly release it through the summer.
I think it's getting close to that, the fuzzy one. Maybe move the fuzzy one.
It should work now.
We'll see if this is better.
Mm-hmm.
So, as I was saying, the beaver ponds, one of the main things that you hear is that they store water and release it in the late summer. And this is one of those things that, as far as we know, is a total myth. There is no real good evidence that beaver dams store enough water on a time frame long enough to change a stream, the stream's flow on the downstream end. So this is one of those things that I think, a lot of times when we get enthusiastic about a particular form of stream restoration, there can be an over-salesmanship. And so beaver ponds are really good at keeping water in that local area.
Can everyone hear me if I just kind of project?
Can I give this back to you then?
Feedback isn't too bad? No. All right. Anyway, so beaver dams are really good at storing water in that local area and keeping that water table high. But you don't tend to see the downstream changes. Really, streams don't change too much when there's a beaver complex in the headwaters. They really don't tend to be that much different if there's no beavers in the downstream. So downstream is kind of a wash again. And then the last thing they do is they really trap sediment and they reduce erosion. And that's one of the main selling points for beaver dams is they can reverse channel downcutting or channel incision. And so because of all these benefits, there's been a large effort to basically do beaver mimicry, which is probably a lot of you are familiar with, is the construction of beaver dam analogs, which are basically our best attempt to mimic a beaver dam. So we build with either pine boughs or willows a dam and then anchor it into a stream with these large fence posts. And what you tend to see is that we like to build these beaver dam analogs kind of in short succession. And the idea is that each one protects the one above it. And so if you're ponding water up to the next beaver dam, you're preventing erosion at that upper beaver dam. So the more of these you can get in a row, the more you're preventing erosion in a stream. Now, generally speaking, the idea here is to get beavers to come into the system to either naturally colonize or to, come into that system through an introduction, basically a release that either CPW or another group would do, and then have them start building on these dams and kind of spread out from there. And when you do that, when beavers take over a beaver dam analog, you can really start to get the benefits of a natural beaver dam. So this is a project I was involved with in Utah. My friend Marshall Wolf, who is a researcher at Utah State, he had a big project where he built a whole bunch of beaver dam analogs. This was the day after we put these beaver dam analogs in. This was just a single threaded channel the day before. Now, from this drone imagery, you can see that there's water spreading all the way out back onto the landscape. And once beavers came in and took this project over, they really sustained that. So why beavers are better than humans is because they're always out there. They're always maintaining these dams. And that's really critical in these restoration projects. A lot of times you'll hear beaver dam analogs talked about as this solution to reduce erosion and to retain water. And that's true if you can get beavers to recruit to it. There's maybe some other benefits to getting wood in the stream if you're building beaver dam analogs that don't eventually get taken over by beavers, but really you get the most benefit by beavers colonizing these sites. They also have some serious downsides, beavers, and that's something that we need to acknowledge. So if you're in more of an urban area, they're really good at clogging up infrastructure. There's a culvert on the left where beavers, they love to go in there and build their dams right at the end of those culverts, totally plug them up. And then you can also have far more serious consequences. So if you just Google beavers and flooding, well, there are times when there will be a large beaver dam that if it gets blown out, there'll be a huge cascade of water that goes downstream, and it's washing these people's home away, right? So it's flooding these people's house. And this is not an isolated example. There are a number of cases where beaver dams blow out and flood people's homes. So basically, when you have a lot of urban infrastructure, having a lot of beavers, it, at the very minimum, needs to be carefully managed. And that's, one of those things where we have to acknowledge that, yes, there are downsides to this wild rodent building dams on the stream. All right, this whole talk was billed as how do beavers impact fish. So I'm sure you're curious to see how that actually occurs. And in turn, see how they impact anglers, which I hope a lot of you guys are as well. And so the first aspect of how beavers impact fish that we're going to look at is fish passage. And so you guys actually have a local boy who's here working on his master's degree at Colorado State. And I'm going to bring up TJ Knudsen, who's going to tell you a little bit about his research at CSU on fish passage at beaver dams.
Thank you, Niall, and thanks to all you beaver and fish lovers for being here. Yep. So I'm going to give you guys a quick snapshot of the data that I collected for my master's project. I still have a lot of analysis to do, but I think some of the initial findings are interesting. They directly relate to some of the things that Niall has been talking about. So obviously when we do this beaver mimicry, we want to make sure that we're doing it the right way. And part of that is after we build these structures, we want to do biological monitoring, right? We want to make sure that it's sustainable. We want to make sure that it's not negatively impacting any of the organisms that live there. And so my big question in this place called Elkhorn Creek is, do these structures impact brook trout movement? Now, brook trout are the only species in this creek. Elkhorn Creek was severely degraded by the Cameron Peak fire, which I'm sure many of you are familiar with. There was also a lot of grazing prior to the fire, so this creek essentially became a single channel, much like Niall was talking about. And so to answer that question, what we did was we captured brook trout throughout last summer in 4 locations. So this whole stretch of Elkhorn Creek is about 6 kilometers long, and this is my whole study area. And we had 2 sections, upper and lower Elkhorn, that were treated with these low-tech process-based restoration structures, mostly PALs, but there were also a couple beaver dam analogs in the system as well. And then the other 2 yellow sections are controls, so there's no restoration structures there. And the idea is we capture fish in these 4 locations, we pit tag them, and then I track them around all summer with waders and basically a backpack antenna, and recording where these brook trout are at throughout the summer. So in addition to doing that, we also collected genetic samples that I'm going to get to probably much further down the road to compare the genetic turnover across these sites, right? Are any of these structures impacting the gene flow of these trout? I also had 2 stationary antennas at the eastern end of the reach to detect any fish that were leaving my study area to account for temporary immigration. And then the western end of the study area was basically bounded by a barrier to movement. It was a waterfall at that location. So next slide. I'm not going to get into all of my data, but the key points are we pit tagged over 3,000 brook trout over 4 occasions. And my mobile detections, we got almost 7,000 detections. So it's a lot of data we're working with. So I'm going to show you kind of an initial look at this data next. So we can go next slide. So the first thing I'm showing you is cumulative movement distributions. So basically what this is, the x-axis is the cumulative distance traveled by each fish, and then on the y-axis is the number of fish that traveled that distance. And I wanted to break this up first by summer and fall movements to see if we could detect spawning movement, because that's going to impact my overall movement analysis. And I thought the screen would be bigger. You probably can't see the scales here, but in the summer, we had over 1,000 fish that didn't move at all. And then you have this expected heavily right skewed distribution where very few fish go really far. So this fish right here went about 2,700 meters throughout July and August. And then if you look at fall, the scale's a little smaller, so less than 1,000 fish stayed in the same spot. You had a lot more movement in the 1,000 meter range, and our furthest fish here went over 7,000 meters in just those 2 months. So it was cool to see that spawning movement, and that means that we have the data that we want to be able to do a good movement analysis. The next thing is obviously the geospatial piece. What does the movement actually look like? So we can go to the next slide. So I used the Tagged Animal Movement Explorer that was developed by USGS. This is a really cool tool if you have any movement data that you want to look at. So these are all of my individually pit tagged brook trout throughout the whole study area and all of their movements. Each color is a different fish. And obviously, you can see that they're not exactly in the channel. I applied some vertical jitter so that you could really see the density of these fish. Otherwise, they'd just be laying on top of each other. So keep that in mind. Next slide. All right, these purple dots are going to be on the next few slides as well. These are the actual restoration structures. So these are the locations of those PALs and BDAs. And so first we're going to look at the upstream end, Upper Elkhorn. Go ahead. So these are all the fish that were tagged in Upper Elkhorn. As you can see, they were able to move all the way through all these restoration structures, and one even made it down to my stationary antennas at the bottom. So that's about 6 kilometers of downstream movement. And many of them went back and forth through some of these structures. So great news. Next we'll look at Middle Elkhorn. Again, this is my control site. There's no structures here. But these fish were able to move all the way up through those upper structures, all the way down through these, and another one made it all the way to the bottom. So our next treatment section, Lower Elkhorn, similar story. All these fish, or not all of them, but a lot of them were able to make it all the way up and all the way down. And then Dahl, obviously, I saw this and I was like, oh no. But this is not due to the structures. There is a private pond right here that is essentially inhibiting their movement upstream. And so this is good to know because when I go to do my movement analysis, I know that I won't include these fish because they were inhibited by some other structure, right? So they will be excluded from my data. So, in summary, we were able to detect that spawning movement, so I'll be able to incorporate that into my analysis. Had some really good distance in summer and fall. Those upper 3 sites, they were able to move through those structures, but obviously that's just a geospatial snapshot, right? I still have to do the statistical analysis on this to see if there's any significant difference between these 3 sites. So that is what I'm working on now. I will say the landowner who owns that pond is very, very happy to work with us in CPRW. So we plan to work with them to build some sort of fish passage so that these brook trout can move up and down with ease. I'm going to build a multi-state CJS model to really look at this data, like I said, statistically. I also have a ton of covariates that I've collected. So we have sex information, size of the fish, body condition, sex bias movement, impact of flow, temperature, all these things that I'm going to look at. And then another sort of side quest that I'm doing is on my first occasion I pit tagged randomly 12 and 14 millimeter pit tags. So they were different size pit tags, and the 14 millimeter ones are essentially new. They're kind of fresh on the market, and they get you a little bit more detection range when you're trying to detect the fish in the water. And so we expect to see greater detection probability of those 14 millimeter tags than the 12s. So that's going to be one of my chapters as well. And then, like I said, I have some genetic analysis coming as well. But that is it. I'll pass it back to Niall. Thank you.
So I think TJ just gave a really nice summary of how the nuts and bolts of a lot of these fish passage studies work. And so what I'm going to try to do is summarize basically the literature and the various studies that have been conducted on natural beaver ponds. And so a lot of that, we're going to look at some case studies from the Bitter River drainage of western Montana. This is actually my home drainage, so I was born in this little town, Hamilton, Montana, right here. Just happens to be the location where a lot of fish passage and beaver dam studies have been conducted. So this is the setting. This is the Bitter River, and it looks like a lot of kind of mountain valleys with the main stem river and then tributaries coming out of the mountains. The 2 native fish that we have are West Slope cutthroat trout, which is very similar to the greenback or the Colorado River cutthroat trout in behavior and appearance. And then we also have a native char species, which is more closely related to brook trout, and that's the bull trout. So both of these species live in the bitter drainage and especially in the tributaries. So first, I'm going to introduce you to Andrew Lahr. He was a PhD student at the University of Montana who wanted to look at fish passage at beaver dams in Lolo Creek, which is a tributary to the Bitterroot River. And what Andrew did was essentially very similar to what TJ did, and tag a bunch of fish and see how they pass individual dams. What he saw was that he also had a whole bunch of brook trout in that same stream, and he didn't actually see any difference in the passage rate between these two species. So the number that we see is that there's an average passage rate of about 63% at any single structure by both brook trout and cutthroat trout. There was another study that I was a part of, again with my friend Marshall Wolf, the researcher from Utah, and this little tributary called Meadow Creek down in the east fork of the Bitterroot River. What we did was tag bull trout in this study and see how they passed through a beaver complex. So here's a map of that complex. These gray kind of squiggly lines, that's the stream itself. So you can see there's all sorts of side channels in addition to the main stem. And then beaver dams of a huge variety of sizes, and including at least 3 really major large dams. So we knew from other studies that bull trout spawn essentially from mid-July to the start of October. And that's when they're making these movements to get into the tributaries. So they live in the main stem, Bitterroot River, and move up into these tributaries. So we knew that at this time they're going to be motivated to move into these systems and to try to get above beaver dams. At least that's the idea. And so what we did was place an antenna array at the upper end of the stream as well as the lower end of the stream. Here's what that antenna looks like. And then we built a little rock dam. So we would basically force the fish to go right over one of our antennas. What we did is then go upstream, downstream, and within the beaver complex, catch a whole bunch of bull trout by electrofishing. Then we tag those fish. This is what happens when you don't have any money for a study. You end up doing your study out of the back of your Prius. We tag the fish and release all of them right below that beaver complex. So here's a few shots of that beaver complex and one of the really large dams. So again, a good variety of dams, and then we looked at how the fish moved through it. We also used a mobile pit tag antenna, so we have those stationary antennas that detect when a fish moves over it. At the end of the study, we went through and essentially took a wand and waved it over the whole beaver complex and tried to detect as many fish as we could that way as well. What we saw is that there were 18 of our 37 fish that actually tried to enter that beaver complex. It makes sense. When we released the fish at the downstream end, about half of them went up, about half of them went down. So of the half that went up, these 18 fish, what we saw was there were only 3 that made it above any beaver dams at all. So there were only 3 that were entering, that we at least detected in the beaver complex. And what we didn't see was any detections at that upper antenna. So no single fish went all the way through this beaver complex. And that's actually not atypical of other species as well. You tend to get very variable passage rates for different species. The highest I've seen is 88% for Arctic grayling. There's a Southwest Montana study, and that's at just a single structure. There's an 88% chance on average that a grayling makes it over that. The lowest I've seen is brown trout, which is about a 5% passage rate. So, it seems like a huge variation, which it is, a huge variation in the fish's ability to make it past these beaver dams. It varies extremely widely by how shallow the stream is, by how big the beaver dam is, and to a degree by species. But one thing I want to know is that even 88%, while that sounds high, if you start stacking up beaver dams, well, you're taking 22% of the fish trying to pass at each of these dams, right? So as soon as you get 5 dams, you're already at only half of your fish passing the beaver dams, even at the most optimistic passage rate.
Would that be 12%?
Yeah.
Yeah. I'm not a math major. So the question is, should we basically just be blowing these beaver dams up? Is that the best thing for fish, is to get rid of these things? Well, we've really only talked about one side of the story, and that's fish passage. And a lot of the history of fisheries management is about removing barriers to fish and their ability to get to their spawning grounds. It's been one of our main focuses in the fisheries science field for years. The other side of this coin, though, is how does it impact populations? How do beaver dams and beaver ponds affect the overwintering or rearing? How does it impact the population as a whole? And so this comes with some of the work that I did for my dissertation. And what I'm going to talk to you about are two kind of paired studies. The first is an observational study where we looked at fish populations across beaver ponds as well as at control sites. And then we're going to look at if those results hold up with an experimental study where we went in and built beaver dam analogs and watched how the population responded. So here's the map of all the streams that we looked at. There are basically 30 different streams from the Colorado border to the Canadian border. And each of these streams, again, has a beaver pond, and then we paired it with, on that same stream, a control site. Here's just a variety of what those beaver dams look like. One of the things you see on prairie streams is that beavers will build with just about anything. We always think about beavers as using exclusively willow. They'll build with sagebrush. Some of these are just mud and cattails. They're pretty resourceful critter, right? They're gonna build these dams anywhere that they can possibly survive. So what we did is we took a big net of seine, we pulled it through each of these beaver ponds, and then we did the same at the control site. What we saw is that across all of those sites, on average, we had 49 fish per 100-foot reach in the beaver ponds and 9 fish in the control site. So that equates to about 2,500 fish per mile. Again, I'm not a math major, so someone should probably check that out. And then 483 fish per mile in the control site. So you're getting much higher fish abundances in the beaver dams. When we look at those species, though, that's just raw fish abundances. The question is also which species are actually driving this trend. So we had a whole variety of species, most of which are native prairie minnows, but then we also had green sunfish and common carp, which are highly invasive species in that ecosystem. What we saw, so that the fish that are grayed out, they didn't really have higher abundances in the beaver ponds compared to the control sites. They had pretty similar abundances. Basically, this was driven by a handful of the native minnows increasing, the white suckers as well, and then decreasing species was those long-nosed dace, which if you go out in the streams around here, you're going to catch long-nosed dace as well. They're really a riffle species. They prefer kind of cobbly flowing sections, so it makes sense that they actually would decline in beaver ponds. The big thing that we found, the big sigh of relief, was that you didn't really see an increase of abundance in green sunfish and common carp, which both of those species are extremely hardy. They even kind of prefer slow water habitats, so there's always a risk that we're going to increase those invasive species with beaver dams. Okay, so that was just the result of this observational study. What we also did was pair it with an experimental study here on Muddy Creek, which is a tributary of the Powder River, which flows out of the Bighorn Mountains in northern Wyoming. And the idea here was that we were going to build these beaver dam analogs on what was a pretty down-cut, kind of big muddy banks stream, that those BDAs were essentially going to mimic that beaver activity, and that, again, hopefully beavers would actually move in eventually and build their own beaver complex. So this is what Muddy Creek looked like before. Fits its name pretty well. It has these very eroding banks. And then when we built those beaver dam analogs, I'm not a beaver, but I think it looks quite a bit like a beaver complex. You get this water flowing out across the channel. Go ahead. And then here is a brief video of what this beaver complex, this BDA complex, really looks like. So again, you can see, this right here is the main channel. We're getting water up and over those banks across the floodplain. And what we did was essentially look at how the fish population changed in this region. So here's just an aerial view of Muddy Creek before the BDAs were put into place, and then here's what it looks like after. So it was about a 2.5 times increase in the wetted area of the spring. We had a fish sampling reach within our bigger restoration reach, and then a fish sampling reach upstream that acted as our control. And what we saw, so this was the year on the x-axis, and then just the fish density on the y-axis, is that you kind of had fish populations bumping around before the restoration took place, but after the restoration took place, you had a large increase in fish populations. And while fish were kind of the impetus of this study, we also wanted to study how it impacts other species as well. And by far the most noticeable change was with northern leopard frog, which is this native frog species. In some areas it has declined due to chytrid fungus. What we saw was that it had a 500% increase. Basically, we saw no frogs before this restoration took place, and then you could almost not move without stepping on it after the project. So that's prairie minnows, but this is a talk for Trout Unlimited. So I'm going to try to summarize some of the work that's been done on trout populations as well. And especially, how do these fish respond when there's multiple species, say native cutthroat trout and introduced brook trout? So the general trend is that when you look across these species, you see that you tend to get larger individuals. So if you like catching large fish, targeting beaver ponds is probably a pretty good idea. You also tend, not every time, but you tend to get higher abundances of these species as well. That being said, literally I woke up yesterday morning, saw a paper that came out of northern Wyoming that had looked at Yellowstone cutthroat trout. They built a bunch of BDAs and the cutthroat trout disappeared. So it doesn't happen every time, right? That's kind of this context dependent. It matters what system it's being built in, but on average, you're going to get higher abundances of trout. Unfortunately, though, across multiple studies, you see that brook trout are the best at taking advantage of beaver ponds. And so when you have brook trout and cutthroat trout living together, if you build BDAs, especially if you promote natural beaver activity, you're probably going to benefit brook trout more than you benefit cutthroat trout.
Unless you remove them all.
Well, if you remove them all, then you're good, yeah. So how do we kind of square this circle, right? We've been talking about how passage is really low. And even when you have relatively high passage rates, as soon as you start stacking up beaver ponds, not that many fish pass. But you tend to get higher populations of most native species in beaver ponds. So, how do we figure out, why we're getting those numbers? Well, there's been a few studies that have looked at how good beaver ponds are for fish rearing. And basically, the reason I'm showing a picture of a beaver pond in the winter is that it is absolutely excellent overwintering habitat for just about all species. So we often think of the summer as really one of the limiting times for trout. Waters are getting too warm. And beaver ponds can, under certain circumstances, if they're big and deep enough, provide some thermal refuge during the summer. But what you see is that a lot of fish move into beaver ponds during the winter. And winter, it's a tough time to be a fish. A large portion of the population of a lot of fish species dies in the winter. And so this overwintering habitat, this is where the easy living is in these beaver ponds. And there's even been studies that have looked at their behavior in beaver ponds during the winter compared to control sites, and seen that fish are more active in beaver ponds. They're out foraging, looking for food, whereas if they're just living in the stream itself, they're just hunkered down trying to survive, which, is pretty impressive work given that these people had to go out and snorkel in the middle of winter in sub-zero temperatures. So shout out to the fish biologists that did that, because I would never do that. And actually, this story about this creek where we saw zero passage of bull trout is also a little more complicated. When we were out electrofishing this system to catch bull trout, to tag them and see how they passed, where we found the bull trout was in the beaver pond. We went upstream and downstream as well, and especially downstream, we didn't find any bull trout. They were all packed into that beaver complex. So that just shows you that even in this study where you have very little passage, we had to get all of our bull trout from the beaver ponds themselves. And that just shows you what good habitat it is. And so, a couple of things I want to leave you with is that this picture shows nicely that you get these areas right below beaver dams where, again, you tend to have that water coming up, that groundwater coming up, which is helping clean out these gravels. A lot of times fish might not want to move up above a dam because they're actually keyed into spawning gravels right below those dams. And beaver ponds themselves, again, are really good rearing habitat. So when it comes down to it, really beavers are this highly, highly beneficial critter to these ecosystems. They have all these benefits to wildlife and aquatic plants, to the broader ecosystem itself. And despite fish passage being hindered, you tend to see these higher populations because of that offset of how good of a habitat they are for rearing. So juveniles grow quicker, they grow larger, and so even if you only have one or two fish make it up above a beaver dam, their young are going to be the ones that survive in that system and are able to prosper. And so you still tend to get this offset where you have a positive impact of beavers on fish. With that, thanks to the organizations that funded this, and I'll take any questions. Yeah, down front. Sorry.
On Nutty Creek, with a 500% increase in frogs, how long was that project? How many?
We actually saw frogs moving in. There was kind of a wetland nearby, and they moved into that site within a week. Yeah. Now that 500%, that was the next summer. 1 year, but it was very quick.
Was ferocity something that you measured in past research, or do you think it's something important to measure in future research? I mean, ferocity of the structures.
Yeah, I mean, beavers are better at building than we are. And we were out there all summer trying to plug these structures up. We hope that beavers will move into that section, but that was a research project. It's very possible that those dams are going to blow out. Now, one thing that you see is that fish passage rates tend to be much higher in BDAs than at natural beaver dams for that exact reason, because they're more porous. So it is an important factor, for sure.
I'm curious, you were talking about plant biodiversity, these beaver dams. How far up and downstream do you see that increase in biodiversity? Is it more like just specifically in those locations where the water's coming out? Or do you see it further upstream than that?
Yeah, I don't know if I know the exact answer to that question. Anecdotally, it's fairly local. Tends not to be too much upstream and downstream. But part of that reason is that beavers are really good at keying in on areas that have kind of a wide, flat valley bottom. And so once you start going downstream, a lot of times the beaver dams aren't there because it's not great habitat for them to build. So it's a little hard to say that they don't have an impact downstream because it's not great habitat for them either.
Obviously, some creeks are better than others for beavers to build there. Did you measure what is the average slope of this stream so you can target your introduction of beaver dam in right location? And the second question is, what happens when you have flooding? What happens to those dams, natural or your man-made? Because clearly, at some point you have some flooding, right?
Yeah. So the first part is that when you're looking at stream slope, there's actually a pretty narrow range, and I couldn't tell you the numbers off the top of my head, but there's a pretty narrow range of slopes where beavers key in on. And there are tools that have been designed by geomorphologists that actually help habitat restoration practitioners key in on that sweet spot. So that is taken into account at the kind of restoration planning stage. And in terms of flooding, a lot of times dams do blow out. On the Laramie River, for example, so where I did my degree at the University of Wyoming, there's a beaver dam on the river right in town that gets blown out every single year. And the beavers come back in and rebuild it every single summer. The reason they do that is to have at least a seasonal protection from predation. And so that's why it's also important to have beavers actually maintaining these and not people, because we're going to forget about it. Funding cycles change. We're not going to have the crew to go out there and maintain these things. The rodents are better at maintaining them. So if you have live beavers, yeah, the ponds blow out or the dams blow out all the time, but they will do the maintenance for you.
Somebody who likes fishing, did you notice? Did you notice any diversity after the dams were introduced in fly larvae, insect larvae, stuff fish like to eat, and going off of her question, the density of vegetation, like where fish would like to hang out?
Anecdotally, you definitely see vegetation, far more algae growth and macrophyte growth in those dams. There's been quite a few studies that looked at macroinvertebrates and how they change, and you do tend to get more kind of pond species that prefer slow waters, tend to get them in the beaver dams. And one thing to think about with these projects too is that a lot of times the limiting factor on a stream is not single channel, riffle habitat. A lot of times the thing that's lacking is that ponded habitat. And so when you get those macroinvertebrates that more live in a pond, you're really going to increase the overall diversity of that stream, even if it's not good for a salmon fly or a squala at that exact location.
This is not my field at all, but I'm curious about when you decide to physically put in these states and physically modify the environment versus reintroduction of species.
Yeah, the question was about when do you build these BDAs versus when do you try to reintroduce beavers. And the answer is actually we tend to do them in conjunction. Because a lot of times beavers, you'll put them in a section and they're a rodent, they're going to go wherever they want. So a lot of times what we do is we build those BDAs to make that the most tempting type of habitat. And so we'll build a few BDAs and then release the beaver. Sometimes they'll even build a little fake lodge for them and release them into that lodge and try to keep them from going anywhere else. Doesn't always work, but it does increase the probability that they stay where you want them to. Far back.
You mentioned that invasive species can get stuck within beaver ponds. Do beaver dams or beavers themselves help against invasive species that spread throughout the ecosystem?
Theoretically, beaver dams, if they're benefiting invasive species, should be sources of those invasive species. So if you do have a place where, say, brook trout are really proliferating, there is genuine cause for concern that may be a spot from which they spread out. So anything that really benefits those brook trout or those other invasive species could lead to them expanding further. So I'd say it's probably the opposite. And it goes to show you that it's important to know what species are in that stream before you start doing that restoration. Because usually what happens is you're not going to create you're not going to get brand new species very often. You're tend to going to create more of whatever the fish is that's there already.
I heard the point made that these native fish species co-evolved with beaver in these streams, and that it makes sense that native species of fish, for example, would do well in an environment in which beavers are doing their work. Curious on your thoughts on that.
Yeah, you hear that adage fairly often, especially amongst practitioners that aren't fish biologists, that are frustrated with the fish biologists that are stopping them from doing projects. And they're not wrong. A lot of these species did evolve with beavers. The question is whether or not it's a fish population that might be able to take the hit. So with bull trout, that's a threatened species. That's an ESA listed species. And so there's real concern about anything that, if it even knocks their population back by 5%, that might not be a loss that we can tolerate. If it comes to, brook trout, good after. So it really depends on how that species is doing, because a lot of times the long-term benefits to the stream of that restoration it will benefit that species in the long run, but the question is, can they take the short-term hit?
Thanks for the great talk, and I'd like to expand on that last question. The title of your talk was the influence of beavers on fish, and I'd really like to hear more about the effect of beavers on small native fishes like we might have here in Colorado in prairie or foothills environments. I know that this is a Trout Unlimited sponsored presentation, a trout bias audience perhaps, but I suspect you've done some research into that, and if you could expound on that, I'd love to hear it. Thank you.
Yeah, none of the population level responses of trout were my own work. The stuff that I did do was those small non-game fish. Unfortunately, part of the motivation for that project was that there hadn't been that many studies on those small-bodied non-game fish. So, what we found was essentially, again, you tend to increase the populations of what's already present. So again, you're not going to, if you have carp and green sunfish in a stream and you build BDAs, you're going to make more carp and green sunfish. So again, you target it in those areas where you have the non-game fish that you want to benefit. And in the cases where those non-game fish are a riffle-preferring species, maybe BDAs aren't the way to go. But again, you have to weigh, is riffle habitat actually limited in that stream, or are we creating a unique type of habitat that might benefit some of those non-game fish? So it is species specific, but you do tend to increase the abundances of all fish that are there, with a few exceptions. It's about the best I can give you, because there just aren't that many prairie non-game fish studies.
Presentation, your math was correct. And my question is more of a basic one. When does it matter? How much does it matter that the fish can't traverse these dams? Like some populations die off in the winter, they need to be replaced yearly, or when does it matter in case it doesn't matter?
Yeah, that's the question, and we usually, the problem is, even the biologists that have the best data that we have from a stream, usually we don't know if, is a 5% decrease this year going to impact the population long term. So I don't know if I have a good answer for you, and that is kind of the central tension that you see between fish biologists and restoration practitioners, is how much can you tolerate? What's the acceptable amount of loss? And you really end up getting to more of a philosophical point with a lot of fish biologists and how the fish biologist for that specific region views beavers. If they think that it's a healthy population and it's going to benefit them long run, they're probably going to okay the project. But if it's an endangered species, a lot of times you get a heightened level of scrutiny. Even that Arctic grayling project. So Arctic grayling are probably should have been a listed species in Montana a long time ago. There's population distinct from the rest of the Arctic grayling population up in Alaska. And even that 88% passage, they decided that was too much of a risk for those Arctic grayling. And they actually made the Nature Conservancy, who was building a lot of BDAs, they made them build these sort of, you'd call them more of like constructed riffles in the BDA, so they kind of create a pond behind them, but there's no issues with passage.
Regarding native fish, I think you kind of touched on it a couple times, but especially the Arctic grayling conversation with the species that have co-evolved with beaver. Why do you think there is this sort of dead end that happens when you have native species that have co-evolved, but you see an issue with when BDAs go in or when beaver move back onto the landscape?
And by dead end, you mean what?
A lack of fish passage.
Oh, lack of fish passage. I think fish passage probably always historically was somewhat low. It's just in a system that didn't have climate change, didn't have habitat degradation, didn't have invasive species, is that most of those populations could take that short-term hit. So I think that's kind of yeah.
With that, okay, cool. Just making sure. With that, is it almost a means to an end that we need to be able to see this hit to see populations come back up? I'm kind of playing devil's advocate. I'm a master's student in conservation, so.
It's a good question, and I think the question is, we don't live in that past ecosystem, and there are these invasive species, and so the question is, are you going to benefit those other species more than the species you're really worried about? And that's going to vary by the system. But again, a lot of smart people that work with Arctic grayling decided that that's too much of a risk.
I have a lot of questions, but first I want to follow up on that a little bit too. I think it's important to think about beaver dams are not permanent barriers in healthy fish populations. Over the long term, co-evolve with beaver and they can move up and down watersheds over the long term, right? But we want to talk about the shorter term impact of beaver dams and kind of the novel pressures that we have with fisheries management. But the question I guess I'll go with is fish biologists, I think, have avoided beaver complexes for sampling for the longest time because of capture efficiency issues and wanting to get good capture probabilities. I'm wondering if we have any advice for fish biologists on how to incorporate sampling in beaver ponds and getting effective populations.
Yeah, don't. Sampling beaver ponds sucks. I had people be like, why the hell did you sign up to do a PhD sampling beaver ponds? You're muddy all the time. As you said, your capture efficiency, how well you capture these fish, is just really low. You're chasing them around these ponds a lot of times. And I was really worried about it because, what if we had showed, well, our populations are actually lower in our beaver ponds than in the control reaches. That could have just been because we're really bad at catching in beaver ponds. So thank God we found the opposite, which, probably means that even despite our poor capture of these fish, those populations were that much larger. So in terms of advice for biologists, realistically, if you have a sampling reach, don't move it if a beaver comes in to that reach, and sample that reach regardless. You may have to change the tools, but hopefully you're doing, not to get too in the weeds, but hopefully you're doing an abundance estimate, not just catch per unit effort.
This might be more of a psychology or musical theater question, but what motivates the trout to jump the dam and move away? Is it food? Is it breeding? Why does a chicken cross the road?
Yeah, I think the answer with the bull trout study was that was targeted during their spawning season, and bull trout usually move upstream into these tributaries, kind of like salmon. You know, they'll move up in those small streams, spawn, and then go back downstream. But you also see fish passage or movement, you know, at other times of year as well. It tends to peak during that spawning season, but fish do move. And yeah, it's other than to say that sometimes they need, you know, kind of thermal refuge or flow refuge. Sometimes they're seeking food. I can't get inside the mind of a trout. She asked if eDNA, environmental DNA, which is basically just a water sample that then you can run genetics on to see what species are there, if that could be used in this kind of scenario. It could, but only if you're thinking that you're actually going to get a lot more species. eDNA is really more of a, are they there, are they not? It's a presence-absence technique. So it's just not, you don't get as much information compared to actually collecting fish and looking at their numbers. So usually this wouldn't be the perfect application, eDNA.
I have one quick question about a thermocline layer. Did you notice any development of thermocline and deoxidation within these beaver ponds that wouldn't result in an increase in trout population or anything? And overall, how is that?
The question is about, do you see kind of temperature stratification in these beaver dams, as well as do you see dissolved oxygen differences? And we did look a little bit at that. The problem with that is a lot of times this point right here differs from that point right there, which is kind of what you're getting at. You do see that more in beaver ponds. I didn't look at it in my studies, but you do see more of that thermal heterogeneity. You see more of that dissolved oxygen heterogeneity in these ponds. And a lot of times, really old ponds, like that big ancient beaver dam that I showed from Alberta, that's probably going to have more problems with low DO, low dissolved oxygen than a brand new dam. They tend to, just like a reservoir, get sedimented in over time.
Has anybody looked at the difference in fish passage between like historic beaver dam complexes that have been around for maybe more than 200 years and streams where surprised they're beaver dams, and is there any difference?
It's a good question. I don't know. What you do see is that dams that have more side channels, which probably would be older dams, dams that have that flow going up and around the beaver dam, those tend to have higher passage rates than something that's just confined to the channel itself. But I don't know specifically about pond age and passage.
When you see a blowout, have you guys measured, do the fish start heading upstream right away because they can, or are they just territorial and we'll do it right here?
The closest thing that I've seen to that is we actually did a different study with bull trout where we looked at their spawning reds. So we counted the spawning nests of bull trout. And one year when there was a big beaver dam that got built in the middle of the channel, they all spawned right below it. And the management agency actually went in and pulled that dam out. They notched it and they removed it. And then the next year, despite there being passage, they still spawned right below where that dam used to be, which it's anecdotal, but it does suggest that there's something about that habitat where that water is kind of coming up from the groundwater that is really beneficial to them. So I don't know if that answers your question, but at least anecdotally, they may not be motivated to move up, at least for spawn sometimes.
I got a question. What would you use to catch a trout?
What would you use to catch a trout? Probably just a worm. I had to say that. He's a TU guy, so I had to make fun.
Elkhart gas.
This is really a great talk. I'm excited to see this research going on. I'm curious, how would you kind of characterize where this field is at this point? Is this still a very useful area study? Is this a mature area study, somewhere between?
It depends on the ecosystem. I'd say in the mountains and with trout, it's fairly well established. I don't know that there's, you keep seeing the variation in, passage is higher here, it's lower there. When it comes to prairie systems and desert systems and these places where the fish are those historically understudied species, this aspect of it is really understudied as well. So I'm a big advocate of more work on non-game fish, on those other species, and maybe get to you involved in that.
You mentioned that you constructed some beaver lodge analogs. I'm wondering, were those areas where you had tried to reintroduce beaver and they didn't stay, or like what prompted that? How much more work was it than building a BDA? And Nate, are we going to be building those soon?
So that wasn't my work specifically. I've seen it done, but the guys at Utah State are really the ones that are pioneering a lot of the BDA work and the beaver reintroduction work. And historic beaver reintroductions, the success rate of getting the beaver to stick right there are really, really low. And so I'd say it's about the same amount of effort. They built it with hay bales, the one I saw, and then kind of put sticks and stuff over it, and they got the beavers in these dog kennels, and they basically just release them right into that little lodge. That part of this field is very much in its infancy, trying to figure out which factors promote beavers to stay there. That study's ongoing, but I don't know the answer yet. It probably helps, but I don't know.
So you don't know in the circumstances whether the beavers stayed around or not?
There are people that do know that answer. I don't.
Okay, thanks.
Who is doing studies on that?
Utah State is really the leader. Joe Wheaton is the guy's name, the professor at Utah State that leads a lot of that work. And he collaborates a lot with Ellen Wool, who gave the last talk. There's kind of a relatively small network of researchers that are trying to improve how these things are working.
A lot of that work's been in the House project and the National Project as well. They're the ones that pioneer a lot of the beaver and
As far as the connectivity issues, is Beaver Dam in similar? I guess it's kind of like a yes/no question of like, when a beaver dam goes in, there's less connectivity downstream. So I'm thinking like migratory species. Is it like building I-25 through the Pronghorn migratory path? But then you also have this uptick in the reproduction of the species when they have access to beaver ponds. Does it kind of seem like a net? Or is there a positive, negative? I guess kind of how did you see genetic diversity and connectivity play into this?
Yeah, I think in terms of genetic diversity, beaver dams are far too transient. Even if they last 10 years, that's probably not going to be a big deal genetically for these species. And they are, most of them are still somewhat passable by fish. So a lot of times what you see is, and I'm not a geneticist by any stretch, but a lot of times it doesn't take that many individuals moving between isolated populations to maintain a healthy population to keep that genetic diversity.
Thank you.
Did you know if there's any studies looking at if the material that beavers are using changes fish path of success, like going from aspen to willow, or you're down in prairie, or is it more mud, pathway, those sort of things?
I am not aware of any studies. It's an interesting question. One of the confounding factors you need to look at is like on the prairie, the slope tends to be much. There is a range of slopes within that area of slopes that beavers are keying in on, and they do tend to be shallower slopes than than, up in the mountains where the beaver dams are. But no, I don't know the answer to that. That'd be an interesting study.
I think we're going to end questions there. Thank you all so much.